In the third part of this video, the final part of this video for lecture 4, we are going to have a look at the same thing that we have done, but this time in Python. You will remember I mentioned to you the markdown. I'm not going to go into that right now, just not to take too long. But briefly, what I'm going to do, I'm just going to start by that nevertheless. So, what we are doing is we are creating a multivariate exploratory data analysis using R. Okay, and here we are going to have, I'm going to send you the complete file later with markdown and everything that you can execute at your own place. But remember that when you are loading your Jupyter notebook, please load it in the directory where you have your data loaded. Otherwise, none of what I'm going to write later will work. So I'm going to send you a complete markdown later that you can just check and also identify and learn how to write the markdown, okay, especially when you are going to produce your report for the assignment. So what are we going to do? We are going to bring this as a markdown and execute that. So that's what we have. And we start by the setup, that is an import. We're going to start by the imports rather. So the import, we'll put it as markdown again, but let me decrease the font by putting a double hashtag as you have seen me doing in the past. And there are quite a number of packages that we are going to install. We will import pandas as usual and give it an npd. I will import numpy. I will explain to you these different um, reasons why I'm importing these different packages. Let me just load it first, and then I will just mention why I'm doing all this. So basically, we are going to load a few more. Don't worry, but right now I'm loading pandas, which is obviously for reading and managing the data set. I'm loading NumPy, which is for numerics, com, com, like a log transformation or other transformation that you might want to do for numeric support. Basically, you have a matplotlib. For plotting backhand, basically you are going to plot your graphics using matplotlib, and then you have a seaborn, which is an easy scatterplot matrices plus heat maps. All these things can be done there, and then I will import something else. um, I will import from scikit-learn. There is min-max normalize. There is this min-max scaler. All right. You remember we need the min-max normalization, and that is available from scikit-learn. So we will need to type it like that. I don't need everything from scikit-learn. That's why you will see that I'm writing it a little bit differently here. I'm writing this module only that I need from scikit-learn. That's why I'm not loading import scikit-learn or whatever it is, but I'm importing only what is of relevance from me. So in other words, if I'm interested with min-max normalization, min-max scalar, I will type it like that: import scikit-learn preprocessing, import from scikit-learn preprocessing, import the max scaler. And then apart from that, I will also need another one, which is import um, plotly. You have already heard about that. We are going to repeat it here, but we are going to say plotly x.express, and we'll give it a name as px. Okay. Now, Miss Plotly Express obviously is meant for interactive parallel coordinates. I also am going to load quite other things as well from this time stats model. There is another package called stats models, and from stats models you have graphics and you have mosaic plot. All these are, so you have mosaic plot, which is found in graphics, which is found from the models package, and you are going to import only one thing, which is called mosaic. Now, what is the purpose of this? Obviously, is to plot the mosaic plot logically. And then I wrongly wrote it, excuse me. Here we go. And then I will also need to compute the chi-square test later. So chi-square test for association, and for that I will need to say from scipy dot stats. So scipy dot stats will enable me to get the chi-squared tests, okay, easily. And that's one thing. And then there is something else that we can load to display, how do we say, for to display tables nicely in your notebook for information. You can import another thing that we call I Python dot display. This is not totally necessary here, but if you want to have a better display of your tables and everything, you can use this IPython.display. You may wish to skip this as well if you don't want, but I'm just showing you something that might be of interest to you. So this is what we have to do here. We are going to execute all these. Now, there is something that I want to point out. There may be a situation that you might have to import other, how do we say, packages, all right? For example, there is a package called PyArrow, PyArrow, and that PyArrow may not be necessarily available in if you are running the code that I gave you, and you see that there is a problem with regards to the parallel coordinates, for example, and you see that it's producing an error. You might have to go through this step that I'm showing you right now, but I'm going to erase it, so just note it down. So you might have to do an installation of the PyArrow package. It's a package that will enable you to load to run the parallel coordinates sometimes, but I'm not going to get into the details of all these, but I'm just going to mention to you, if you have to install, it's a bit like in uh, where you do install the packages. It's a bit the same thing that I'm doing when I'm doing exclamation mark pip, and then I put the name of the package that I want. But then loading is like import in Python. Like when you type library in R, it's a bit like analogous to the import in Python. Just for information, this is something that you might have to do later. Please note it down. I repeat, just in case this is of relevance later. So we're going to execute them, and then we're going to import our data set and do some quick checks. Okay, so in the meantime, but like while this is being run, let me just check what the issue is. Chi-squared contingency, sorry. That should work now. While this is going on, so it has worked, by the way, because you know that there is no asterisk here, so it has worked perfectly well. So our next step is to import our data set. So in the first instance, what we have been doing is that we have been doing the setup and install the packages. We can change this to load packages, just to avoid confusion, by the way. Here, this is Markdown, so I'm going to import data set and I'm going to change that to Markdown. But I'm going to give you a complete Markdown later for reference. Now, first thing, I'm going to call it df. As usual, I'm going to get this from pandas read underscore csv. I'm going a bit fast on that because I've already gone through a different video. I'm going to put the name of the file, and the name of the file is customer multivariate. Let me just check that quickly. Yes, demo, not CSV. And you can print the first few rows, you can obtain the display of the first few rows. So you can say display df.head, a little bit what we have already done in the previous video. And then you can have also information about the data type, data info, and then you open here, and you can also display numeric summary like describe through the function. I'm using display y because I don't want um, the last, if I don't put display here, I don't put display here, and I don't put display afterward, what would happen is that, like here, I did not put display, this information will disappear. I won't be able to see it. So I need to put display data df dot info to be able to see all of them in that particular cell directly. Otherwise, some of this information will not be available and not seen. Okay, that's one thing. And then I'm going to say display df dot describe, and then I will say describe. Well, there's no need for that. In fact, let's skip that part for describing of numeric vectors, because that doesn't bring much information. Sorry about that. So let me just execute that, and then we'll see you get the information of what are these integer or numeric variables quite from here directly, and you see that's fine. These are objects. Objects are mixed of data types in Python. Generally, they are probably text that are wrongly, that are not classified as character, but they are classified as object. So sometimes because there is a sort of mixed data type, a bit generic data type, that Python consider that. So we again need to fix that issue of segment, region, channel, and product here, and obviously make the amendment to fix these data type. Okay, so that's what we're going to do now. We are going to start with. So what are we going to do now? We are going to fix data type. Markdown, execute, we come back here, and we are going to start by fixing the data type by typing df. We start by customer id. All right, the customer id, we not start by the customer id, it's already integer, so we don't have much to do here. All right, we don't have much to do. Whereas for segment, channel, and region, we will have to do something, except for product here. I'm going to discuss that later. But for segment, channel, and region, you know that these are categorical in nature. So I have to do something to get these types represented as they are supposed to be represented. So for that, we are going to do for. We are going to put for the column are in segment, in channel, and in product region, sorry. For the call are in these, if you come up to be in these column, for if a column is segment or is channel or is region, what you're going to do is that you will say df of col equal to, we are overriding, in other words, the current call that you are going to do. So in other words, if if call is segment, so df segment is going to be overridden by df call again, dot as type, and then we put the name category, which is analogous to factor in R. So that's all you have to do. When you are doing that, you are writing a for loop. You will see that there is this way of writing a for loop here. Look at the syntax. So you are saying for your iterator being in segment or channel or region, what you have to do is to replace the current column by the proper data type, which is category. And you repeat that for channel, you repeat that for region. That's the kind of principle that you have to do. And you also have an ordered categorical variable. So I'm going to call it product order to define the order in which these are meant to be. So you remember there is basic, there is plus, and there is premium. So I'm going to already write them down in the order I want them. So we start by basic, which is lowest, then you come to plus, and the last one is premium, obviously. And that's one thing. Then we want also to so in other words, what I just did here is I'm just creating the order of a product, and I'm going to replace the product here by a new variable using this product order information that I just mentioned here. So we come back to the same thing, product tier. Now this product here is equal to, we are going to say from pandas, we are going to say dot categorical, which is a function used to replace these, how do we say, to replace these different columns from what they are object to categorical, okay? Then we are going to say df, we are going to say df product here. We are going to add more information because this categorical, the advantage is that if you just say product tier categorical, it will normally consider it as a nominal variable, but in our case it's not really nominal, so we need to state that, and we'll say that the categories of this categorical variable, that is the levels, are the product order that I've just defined. So in other words, the categories are in that specific order starting from basic to premium, and you will say, of course, ordered equal to true. That's the main thing that you have to do. If you don't say ordered is equal to true, that would not work. We move on to the next step, which is the churn. You recall that it is 0 1, but we have to plot categorical plots for based on churn, and for that we are going to repeat a little bit the same kind of story here. We have churn PDF categorical, and then we are going to replace the current churn. What is the current churn? It's not really churn, but it is churn 1. You would recall that. In fact, I'm just repeating what I just did in you would, so 0 underscore 1. And then what we will do is we will say dot, I will need to erase this here. I will keep the order is equal to true because it's a product here, and it is not product here, but churn. I will keep the order as it is equal to true, starting from 0 to no, and 1 to represent yes, but it doesn't matter much here whether you say it is ordered or nominal or whatever it is. Yes, so what I want to do is that in this churn, I will say the category called df churn 0 1 should be mapped. It's a function that allows you to map certain categories. Like here, we will say 0 represent no, and you will say 1 represent yes. I just want to remind you of something, everyone, is that when you are looking at all these codes, I'm not expecting you to know all these codes by heart for sure. As I said to you earlier, you need to understand at least what this is doing. That's important. If I give you something like that in class test or class test, so what you would expect is that I can ask you to explain what this is doing, but I'm not going to ask you to write the code yourself. That's not the purpose. Just bear that in mind, please. So then you will say, what are the categories? The categories are no and yes. And then order is equal to true. It doesn't matter whether you put order is equal to true or not, by the way. It is okay here. So we'll end that. And then we can again display our data type, dft types, to see whether these has been changed properly or not. Let's have a look. No, yes. What did I do here? Oh, forgot the comma. Here we go. So you see that these have become categorical variable. This is integer 64 as usual, but churn is category. So data type is so here we go. Churn is category. What That's what we have, and then we can display df data type. We can also display df dot head. You can execute that. You'll get the first few rows, the first 5 rows in that data. Our next step now is to draw the pair plot or the scatter plot matrix. That's the same thing. So now we are going to have a look at the pair plot, and to remind you that the pair plot is want to answer questions like it's also referred to as categorical and as I mentioned, and the idea is that it wants to answer questions like which numeric variables relate to each other. Are there outliers? Do groups separate? Things like that. Okay, do we have clustering in there? So the main function that we are going to use is the package from Seaborn. We are going to use pair plot function. That's a main package that we are going to not package but the main function that we are going to use from the Seaborn package, as you are seeing. Okay, and we are going to play around with that function to be able to draw a grid of plots. So we'll start by writing our function. To start with, we need to have our variables, which are numerical, obviously. I just check quickly if I've just noted that. No, I did not do this. So what I'll do is I already have the list of variables somewhere. I'm just going to copy that. So these are the variables that you want to include here. These are the variables that you want to run a pair plot on. And in how we have done that, we have defined our varnums, and we are going to do the same thing here. At the same time, you are able to see a little bit the difference in the ways that we write down these codes. So it's a little bit different, as you will see. In how you will say C bracket, but here you see that the square bracket representing the different columns that you have there. And then we can execute that if you wish, and then you can type display varnum. Bon, enfin, there's no need, but if you want, you can do that, display varnum. And I will erase that anyway. You will see that these are the variables that are included just to ensure everything is here. 1, 2, 3, 4, 5, and 6 variable. It's already there. Good. Let's move on. The next thing is you can draw the SNS pair plot, as I mentioned to you. That's the main function that we are going to use. In the SNS pair plot, it's just like a bit the same idea that you have done before. You'll need to define your data first, which is the first argument that you want to pass on in that function. The second is that you need to state what variables you are going to use in that data frame. The data frame df contains all the variables, but you are interested in only a set of variables that we will define as var num. All right. So we need to say that because we don't want the whole set of variables to be included, because many of them are categorical. That's why I defined the varnum earlier. And then you will want to separate these different points in the diagram by group, like by segments. Okay, for that you want to change the hue, which is the color, by segment. You will let Python do the work itself. You don't need to worry. And then there is an option where you can do decide on whether if you don't do that in Python, it's a bit different from the case in R, because here, if you don't do what I'm going to show you, you are going to get an exact replicate of the points in the lower diagonal, and in the upper diagonal you will get the same information, obviously on a reverse scale, but the same interpretation. It's a bit worth less to do that because we don't want to use maximum data inc for no we want to maximize data inc, and we don't want to have a repeated information. So what we want to do is we will put corner is equal to true. You may wish to try it with corner is equal to false, as I mentioned to you. That is something that you will do later yourself. You can just have a look what it will give you, and then you may decide what you want in the diagonal. You might want histogram, you might want something else. It all depends on what you expect in the diagonal. So for me, let's suppose I want the histogram. So what I will do, I will say diagonal kind is equal to hist. See, that is the histogram we are going to get in the diagonal. And then there is another parameter that I'm going to pass, which is plot KWS. And this plot KWS, it affects the scatter plot, where you are going to put in transparency and where you're going to put in the point size of the points, how much you want them to be big or not. The transparency is to control how points are overlapping or not. So what do we do here in this parameter? We are going to put in between inverted bracket the parameter that makes the point transparent or not. So we will say alpha is, and then you will put the value that you want. For example, if you want 0.35, you can put 0.35, you can put 0.7. It's up to you. You see what is appropriate. And then there is another point, which is going to be the S, which defines the point the size of a point. You can leave it as default. You don't need to do that if you wish, but you can also play around with these. For example, let's suppose I try this value of 20. You can check what you get, and if you want, you can play again with these arguments to see which one is more convenient to you. So we can plot that, but before that, let's do g. This I need to put a name here. G equal to SNS. So let's put the G equal to G dot add legend. We want to add the legend here, and the legend will be where we want to give a title to the legend. The legend will be in terms of a different colors, and it will be referred to as a segment. So you are putting a title to your legend that you're going to get because you are using use segment as you would record here. So the title is equal to segment. All right. The other thing, you can put S capital here because it's just a title that you will get in the diagram. You don't need to use a small letter s here. You need to use small letter s to refer to the variable here. But in that particular context, you are not using necessarily small letter s. You can write it as you wish. It's just a title. And then the other thing is that I can add a title to this graph. So you can do plt, the plot dot subtitle. So what is plt dot subtitle? You are using G here, but this G is going to be overlaid on a matplotlib frame. So in that matplotlib frame, you can add your title and you will say what you are doing. For example, I'm doing a pair plot or scatter plot matrix. All right, colored by segment. That's what I want. And then you can play around with this where the title is positioned. For example, I can put a value of 0.1.02, and I can play around with this argument. I already explained that in the previous lecture. So you can play around with this argument to show where the where would it be in terms of the if it's going to be far higher, if it's going to be lower, in terms of the positioning, in terms of a title where you want it, you can do that y is equal to 1.02. And again, you can play around with these later to see what it gives you. So we'll just execute that and see what it gives. So first of all, there are some issues already appearing as you are seeing. We need to solve that issue. But let me just check if we get our plot first. Yes, our plot is here. You will see that there is no upper triangular, there is no upper triangular triangle, right? Because we have set this corner is equal to true. So if we set corner is equal to false, you would have got the same information on the reverse side, obviously, on the other on the other diagonal here, right? This would appear here, and then this would appear somewhere here as well, and so on and so on. So there are some issues here. First of all, I'm not going to go through the interpretation of all these. I've already gone through them in R, but what we will want to do is we want to normally check here if the graphic is going fine, and you will see that there are some issues here. You see, for example, it says the segment is blue, orange and green, but you don't see the orange, you don't see you see rather a gray bar, because there is a small problem in this graphic. Okay, you have to be careful where in these kind of graphics. Sometimes I prefer, as I told you personally, I would prefer such graphics to be done in R, but still, if you are doing it here, you have to be careful with these issues that you are seeing here. Okay, and how do you solve these issues? First of all, let's fix this problem. You will see that these are future warning each time that is being given to you that you don't want to see. This is just for information. What are the different things? So before you run these, maybe what we would prefer to do is to import warnings, as I again explained to you earlier in other lectures, where we are going to filter out this specific warning, because we know that there is only one warning that is being discussed here, which is a future warning. So we will filter warnings, and we are going to say what warning you want to filter. So category equal to future warning. Write it down just like it is write it down just like it is written here, future warning. But then don't forget, the other thing is that you need to say that you need to ignore this warning. Ignore this warning. Okay, we are going to execute that just to see if the warning is over. But there is another issue, as I mentioned to you here. This is the issue of the overplotting, where you have several colors being mixed together, making that interpretation not so easy when it comes to identifying what segment relates to what segment. So maybe what I will do is, instead of filling the colors, we can put a histogram without the filling. That is, we don't have the green filled in the rectangular, but a blank rectangle, if you want, a rectangle which is without any colored filled in. So what we want to do is add an argument here, and we'll say diag kws, excuse me, kws, and we will say that we want uh, fill is false. That would help to fix that issue where you have uh, an inconsistent, how do we say, an inconsistent legend being shown, grown in the uh, histogram. So let me just execute that. Just wait a minute, and then we just see what's going on. Here we go. You see that's better now. You can see the distribution of VIP segment as you are seeing here, and you will see that VIP segment generally they are lower in terms of number. all right? But then you see that most of these distributions seems to be positively skewed, irrespective of whether they are from a particular segment or not. So most of them are positively skewed. So let's move on. That was for um, the case of the pair plot. Okay. Now we are going to get into the parallel coordinates. That's the next step. We're going to get into the parallel coordinates, and we are going to make it interactive also as well. All right. We want to ensure that the parallel coordinate is already interactive right from the start. If you want to do that, I will show you how to do it. Okay, I'm going to make the parallel coordinates directly, and it's preferable to have it interactive because even if you don't have it interactive, you can see it how it looks like directly from the graph. Maybe for the parallel coordinates, you might prefer, for example, to use Python here because you will see in a moment that Python is far better on that side, but it depends again. Let's execute that. So here, for information, before we get into the parallel coordinates, just remember something is that we will need to apply min-max normalization, all right? And for that, we will need to do that, and we will also uh, have to use Plotly, the same package that you heard before, Plotly, which is an interactive package that we are going to use to be able to draw our parallel coordinate. So let's get into this. First of all, you will have two things. You will need to create a scalar that we will refer to as min-max scalar, and then we will use that scalar to fit our min-max normalization. So let me just get into that to better explain what I'm doing. Uh, so we want to have the same variables that we have except for h. You would recall. Where is this? Here we go. We're just gonna copy that, come here, and we are going to give it a different name, obviously, just like we did in R. So we want the income, we spend, the visit, we want the tenure months, we want the satisfaction, but we don't want age here in that particular example. It's okay if you want to put age, it's all fine. I'm just saying that I'm not using it here in this particular example, so it's like this. Now the next step is that we want to apply the max normalization on these variables, obviously. Now, to avoid any issue, we want to create a temporary data set on which we are going to plot that parallel coordinates just to avoid any issue in terms of overriding the current df that we had originally. All right, just to avoid overriding this df that we have defined originally, I want to keep that df as it is, but create a new sort of data frame that is going to be temporary, where these variables like tenure month, income, etc., will be converted from 0 to 1. So for that, I will do that first just to avoid any issue, and I will call the data temporary temp here, and we'll say df dot copy. When we say df.copy, it means that you are going to have a copy of your df, but instead of working with df, you're working with the temporary data frame that you're working. And then we are going to use a scalar, which is going to be equal to min. It's up to you how you want to call it. You can call it scalar, you can call it m, you can call it whatever you want. And I'm going to say min max scalar. That's the way you write it. Just ensure you write it as M capital, and S capital here. And then we are going to apply this scalar, that is min. Instead of typing min max scalar dot whatever it is, we are going to say scalar dot, and then that's where we apply the min-max normalization. We have not yet applied the min-max normalization. We are just saying to R what transformation you have to do, and that transformation, that is fit transform, will be this fit transform that we are writing here will be based on that scalar. So if you were to use a different scalar rather than min-max normalization, you would have used the function that correspond to that particular transformation that you want, and you would say scalar again. You can call it whatever you want, and then you will do fit transform. All right. Now you have fit transform what? You want to fit transform the variables that you have, and these variables is from the temp data frame, and the variables are called var pc. Okay, so this is the variable that you want to transform, and again you want to override the current data frame that you have created, and you will put in the same thing here. So in other words, what this is doing is that it is applying a transformation, which is the min-max normalization, on those variables that are found in that temporary data frame that we have created, and we apply that scalar, which is a min-max normalization. When we say fit transform, it is general. We could have all kinds of transformations. We could have standardization, etc. But here I'm referring to the min-max normalization. So then you apply that transformation and just override the current variables that you have. So instead of overriding the data frame which we had originally, we are overriding a copy of that data frame. So we are not playing around or messing up with our data frame. So if you want to have a look at the display, you can do tmp.head if you wish. That will give you an idea of what the data frame looks like. So you see that now we are having all the data that are numerical, which have been transformed. The rest stays as they are. But let me get rid of that because this was just for you to see. Now we are going to plot the parallel coordinates directly. To plot the parallel coordinates, we will use a main function called parallel underscore coordinates. That is the function that we want to use. And that function that we want to use will be, here we go, will be from this package plotly.express that we have imported earlier. So we will use px to define that package, to define that function. It is from the package px that we are running this parallel coordinates function. All right. And we are going to give it a name. Obviously, we'll call it fig, and then from the parallel coordinate we will do enter here, and we'll start inputting all our different arguments that we have. So first of all, we have a data frame which is 10. That's the way to write it down here. We'll have the data frame which is tmp. That's one. We'll have a dimensions, which is, you see, the way of writing is a little bit different, so you need to be careful with that. It's not exactly as we have been doing so far. Here we are going to say data frame. Here we say dimensions. The dimension is var pc. These are the dimensions that we are working on, and you want to differentiate by churn as we did in the previous example. So then we will say color, and then you will put the name of a variable as it is. Remember that it should be numeric. The same principle applies here. It should be numeric, so we are using that particular variable. We need to ensure that we write it exactly as it is. Plotly color scale is based on numeric variable only, and then you would put a title here directly. You see, it's a little bit different from what you have been doing so far, so just ensure that you don't get confused with these different ways of doing things. So you have coordinates, parallel coordinates, and then you say we'll apply the min max scaled colored by churn. Colored by churn. So let's talk about that, and then we can just, by the way, if you want, you can just type this like this. I've already explained that to you, or you can also do fig.show. That is going to do the same kind of thing without giving you unnecessary details. For example, if I do this here, I can erase that and we'll see what it is. Just execute that. Just hold on a few minutes and then we'll see what happens. Oh, sorry. I need to type fig anyway. Okay, it's not working, so let me just go. Sorry, sometimes there are certain things that you want to try but it doesn't work. So let's do the fig show itself. Excuse me. So we are having a problem here. Loading chunk 478 failed. I think it's a matter of how do we say memory space. But let me just check if I did not do any mistake in the codes here. PC churn 01 parallel coordinates colored by churn. Okay, then you have figure.show, you have a temp, you have a valve. So all these seems to be good, but the only issue that we have when you see these kinds of things here, generally it's an issue of memory that you have. So what I will do, you just give me a few seconds. I will try to close that thing, and I will try to execute everything from start, restart the kernel. Okay. So normally when you have such kind of error, JavaScript load chunk or something like that failed, it's generally an issue of memory. And what I had to do is, sorry about that, I just run it and I had to close everything. I had to close Python complete, Jupyter Notebook completely and open it again. That After I've opened it again, then I've restarted the kernel from the start itself and uh, get everything done. So now you see that it is working with the same code. I did not change any code here. With the same thing, it's just that sometimes this error happens and that you have to solve this issue by closing everything Jupyter Notebook completely and come back and open it. If it happens, it depends on your computer resources generally. And here you see that you will have a scaling of that particular variable of churn. Here in our case, there are only two values, 0 and 1. We don't have anything like 0.5 or whatever. That's why you are getting only two colors, blue and yellow. And you see that these are the same kind of thing that you can do, change around these axes. Same thing. I'm not going to interpret that again because I already discussed it in the previous video for R. We are getting the same thing done, just using a different language. All right, that's all. And then you have the same kind of interpretation that you have before. You see that you can select and brush over the axes to be able to select particular points out of it. Okay, these are the kind of things that you can do. So that's the parallel coordinates as it is. Similar thing to R. The only advantage is that you have the legend defined clearly here. In R, you might have an issue sometimes with regards to that legend. We can do the same thing now for segment if you wish, by the way. Maybe what I'll do to better illustrate that, I'm going to copy that piece here and just bring this down. And I will call it temp2, and instead of df I will use tmp because tmp has already been scaled. All right, so I don't need that part here. I can erase that immediately, and the only thing that I need to do is to work out the segment code. Remember that churn take not churn but the plotly will take into account only a continuous scale for the segment for the coloring, okay, for the categorization. So what you want to do, if you want to include this, we will need to do say temp2. So let's do that first of all so you better understand what I'm talking about. tmp.head. If you do tmp.head and we do display here, um, and then let me just erase that so that it doesn't take long to run. So if we do that, you will see that there is this segment which is categorical in nature, and this won't work on that scale. So we need to replace these values by 0, 1, and 2. So that's what we want to do. Okay. So in other words, if you want to do that, so let me just paste the code down there again. And if you want to do that part that I'm telling you, you need to change the temporary to file where you are going to modify segment code only. We are going to call it segment code. segment code. We are going to give it a name, an additional column in that temporary file, which is going to be temp2 based on segment. And then on that segment column, we are going to convert these core value, etc., VIP into categorical codes. To do that, we do cat.codes. When you are doing cat.codes, you are applying a codes on a categorical data, which is based on the variable segment, and you are creating a new column in that particular data frame temp2, which is going to be called segment code. And then if you do display tmp2, you will see that there is going to be an additional column here, which is going to be segment code that will replace all these core value, etc., by values like 0, 1, etc., etc. Okay, that's the idea behind. And then you are going to call it figure 2. We keep that as it is. Then we are going to change that to 2. Excuse me. We're going to call it figure 2. We're going to change that to 2. The variables stay as they are, vars PC. And then the only difference is that we're not going to use churn 01, but we are going to use segment code. This I did not explain in R, but I'm just explaining it here for information. And this one is colored by segment. Okay, so you can play around with that again, and we can execute that. By the way, I hope it works, otherwise we'll have to restart everything. So here we go. We get the same information now. It's not churn, sorry, just a second review. There is something wrong now. We need to check what is wrong. So supposed to be churn 01, but colored by segment. Maybe the segment code did not work well. Let me just check this. I'm getting the same. Just hold on a minute. Oh yes, I'm plotting figure two. Figure two. I need to do. Sorry. Figure two dot show. Let me just check. Here we go. Figure two dot show gives you the segment code starting from 0, 0.5, 1. By the way, if you want to know what these codes are in a very quick way, you can do display temp 2 dot head very quickly without getting to, or you can do glimpse of temp 2, all right, as well. You'll get a better picture. So you will see here, for example, core is rated to 0 and value represent 2. Of course, VIP represent 1. So 0 is core, value is 2, and 1 represent VIP. So the interpretation, you will see that there is a lot of VIP which spends a lot, as you see here. It's a bit on the high side. The VIPs tends to be on the high side. The yellows, which represent the value segment, are relatively lower, etc., etc. So that's it, how you can do parallel coordinates as you have seen. All right. Now our next step is to do a mosaic plot, and that's the last step for this lecture. We have also the stack bar chart, by the way. So let's talk about the mosaic plot now. So we're going to work with the mosaic plot now. So as you will recall earlier, to be able to build the mosaic plot, we need to start by step one, building a contingency table of accounts, what I'm going to explain to you. Then we will need to do the conditional proportions. It's optional to do that, but it is preferable that we do it because it becomes easy to interpret. And then we can run the chi-squared test as well to accompany that plot to better have an understanding of whether there is an association or not. And then we can then plot the mosaic plot. We can also do the stacking later that I'm going to talk about. So first of all, we give the same name, tab segment, excuse me, tab segment churn. Tag segment churn, and then we will use cross tab, which is obtained from pandas itself, and the cross tab, we are going to use the variable segment, and we are going to do it on churn. But I'm not going to write, excuse me, each time I'm writing this like church. So we are going to run well segment here, not capital segment, but and then churn. Okay. So this is, you can't write it down like this. You generally you need to refer to the data frame, as you would recall uh, in other examples, and you need to do it like this. Okay, not over. You will also need to enclose that in between inverted comma. So that's what we do. We are going to display that table here, display that table as you are seeing, and execute that, and we're going to have a look at the table. Again, I'm not going to interpret that, just for information. If you are looking at this video first, you need to have gone through the second part of the video to better understand the interpretation behind what we are doing, so that we don't take too long. I'm just skipping that step of interpretation, so otherwise the video will become a bit too lengthy, and it's going to be a repetition of what I've already done earlier. So let's move on, and we are going to talk about now the conditional proportion that I can do. Now, for the conditional proportion, we can just run that code here separately. You can just use display here. I'm just going to add something to the code that you will see. Within display, I'm just going to include an additional information with regards to the cross tab function, where I'm going to say normalize, and we'll say it is equal to index. Now, what is this normalized index doing? This normalized index is basically telling you that you need to normalize the rows of these contingents table to sum to one. That is, in other words, it will give you the probability of a column given a row. That's the idea of normalizing based on index. All right. These are terms that are specific to Python. I repeat, you may not be familiar with all these terms when you are listening to all these, but as if you were to do it several times, obviously you will get to familiarize yourself with that. But it doesn't matter when you have to study how to write a code in a work context. Generally, you would need to understand the steps. For example, if you want to draw a cross tab, you need to understand that first of all you need to draw the not a cross tab. If you want to draw a mosaic plot, you need to at least understand the concepts of that. You need to start with drawing the cross tabulation first. And if you don't know how to draw a cross tabulation, you can easily Google it to understand what to do to obtain the cross tabulation in Python. That's not a problem. But the principle stays as it is. You start by the table first, then you are going to draw your cross tab. Now, like this one is optional. There's no need for me to do that, but I'm doing it just for the sake of interpretation. As you will see here, it makes things easier to interpret what's going on. But I'm telling you, I'm going to skip that part. I'm not going to get into the details of that part. The next thing is that I want to get the chi-square test, as I mentioned to you earlier. Now, for the chi-square test, I will need to use a function called chi2, chi2 underscore contingency, and then it's a function that I'm going to apply on tab section, and this tab section is based on the pandas package. All right, so this function will be applied on that, and what you need to do is, if you run this function of chi um, if you run this function, let me just try something, please. So you will get all these information as you see here. If you run this function as it is here, you will get the contingency, but it's a bit messy and very not nice to view and understand. You are interested in certain information here. For example, I'm interested in the statistics here, which is the chi-squared. I'm interested in the degree of freedom, for example. I'm interested in the p-value, for example. These are the only thing I'm interested in. The expected frequency is not of relevance here. So what we want to do then is instead of getting all the results at once, we will just first of all get rid of that, and we will remove that here, and we will remove that, and we will say which are these results we want, which are these results we want. We want, for example, the result that relates to that particular instance here, all right, which is referred to as a chi2. We will need the p-value, which is going to be defined as p, and we'll need the degree of freedom. Now, the naming here convention, you can use it like that. You will say, okay, I need the chi2, I need the p value, and I need the DOF. All right, I need the uh, statistic, the p-value, and the DOF. These are what I need in this graphic. That's basically what I need. And you also have expected, which is what, but I need to write it down though, which we're going to call it expected. So what I'm doing here when I'm doing that is very simple. I am calling the statistic as chi2, which is the convention, which is simple to understand, and p-value as p. I'm writing DOF as it is, and I'm writing expected as expected frequency as expected here to make things a little bit simpler. So in other words, it understands that when you are returning this chi-squared, you would have the first value which correspond to that, the second value correspond to that, the third value correspond to that, and the fourth value correspond to what you have here. But I'm not interested in this expected, but still I need to write it down here so that I call it this way. And in the end, I'm interested in only these three. So what I do now to get these three, I'm going to use a function called print. And in that function print, I'm going to use something that we call string literal. What is this string literal? We'll start by writing something within that string literal, and we'll start by a new line. Whenever you see me writing /n, it means that you are going to write, instead of having this messy result here, you will say that I'm going to write a string literal which includes certain elements. What are the elements? For example, I would want to say, to write something like squared, chi-squared test between, sorry, here, and then I will say excuse me, then I will say chi2, which is a chi-squared, is equal to. Now, listen to me. If I just print that as it is, this is what you are going to get. Chi-squared test chi2. When you say /n, it just ensures that you don't have something that is just below this. It just gives an additional line before you start writing this chi-squared. So it's just a new line. That's what I get if you stop there. But what is the advantage of this string literal is that inside you can include values from your results. And each time there is this curly bracket, it is going to tell you basically that inside this code, anything inside this code here, this string literal is that inside this code, everything that is inside the inside the curly bracket should be replaced by the value of a variable or an expression. That's what it is. So, in other words, there is an advantage when you are doing that here is that it enables you to include the value of a variable in addition to your string literal that you are seeing here. Okay, that's the main advantage that you have here. So let's talk about what you want to write. For example, I want to write this information here, which is a chi2. In other words, it is, I'm interested in this chi-squared value. So I put chi-squared value. So in other words, it returns a chi-squared value, but I can return that. Let me just execute that for you. You will see that it returns a chi-squared value with which we have determined earlier. I've already removed that But anyway, you would remember that when I did chi-squared tab, I had the chi-squared value as it is here, but I don't want all these. For example, let's suppose I want to have only three decimal place being included, only the three values after the decimal place rather. If I want to do that, I can come here and I will do an additional formatting here, which will say dot free f. When I say dot free f, what does it mean? It will return only the three decimal places, that three, not decimal places, the three digits after the decimal value. And here it is 2904, which is, of course, it has rounded it to 904. That's the advantage. So basically, when you say dot free f, you are talking about three decimal place. That's not over. Now you put comma, and anything in there would be considered as a string literal, a string, except when it is within the quotes. Whenever it is inside the quote, it means that it is a value that I need to extract somewhere. Otherwise, anything that I want to write here will appear in the output below. But here, for example, I will say DOF, which is a degree of freedom, or I could write it as degree of freedom if you want. And I will need to extract that degree of freedom. Sorry, I will need to extract that degree of freedom right from the name that I've called it here, which is DOF itself. Okay. Now, the next thing is not over. We want also the p-value, uh, DOF. We want the p-value. So we call it p-value. Again, when you write p-value, it means that in the output, there will be p-value that appears. And then you will say equal to, and you open and you close the bracket and you put the string. Don't forget to put the code here, please, to close the code. So p-value is, for me, I've defined it as p. So I will type p here. All right. And p, you decide how many degrees of freedom, not degrees of freedom, how many decimal place that you want behind. So degree of freedom here, you don't need to, um, it's only a single number, so there's nothing to do here. But for the p-value, you can say, I want only four decimal places. So you write like this, dot four f, which means that after the decimal place, there are only four values that will be observed. And you can execute that. So let me just check wherever there is a mistake here. P-value, oh, sorry. This is, I need to close that, okay? I need to close it with the curly bracket. There we go. Now we get the chi-squared, chi2, DOF, p-value, etc., etc. If you want some spaces in there, you can also put the space or whatever you want to do. It's up to you. You can play around with this string literal. Now, the next step is to plot the mosaic plot. That's something that we want to do now. To plot the mosaic plot, we want to say mosaic, and then we are going to do mosaic tab section, and then we say dot stack. That is what's going to give us the mosaic plot. Now, when I refer to the table dot stack, what I'm talking about is that because mosaic expects a category 1 and category 2 count structure, all right? It expects it to be like that: category 1, category 2 table structure. So count structure. So the issue is that uh, this has to be written in that structure as you see here, right? So let me just do something to show you better what I'm talking. Oops, let me delete that for a moment and then I'll run that again. So that kind of structure I expect. You see, you need the category 1 and category 2 count structure like what you are seeing here. It's not exactly the contingents table that you are expecting, but it expects this structure to be able to draw the mosaic plot. So that's why I had to do this dot stack for your information. I can't just run it directly from table churn. I would prefer to do that dot stack. So that's why it's good to do that, so that we can run the mosaic plot clearly. So let me just remove this. Instead of saying display, I'm going to say mosaic.stack, and you can automatically get the whole thing right now. Here we go. You get your mosaic plot, which is not bad, but at least we are not having all these troubles that we had earlier. But it's a bit like the basic plot, mosaic plot in base version of R, where you are shading the different segments here in that particular example. Now, the it all depends also on what you have decided in terms of the rows and the columns. If you were to replace churn in segment and segment in churn, the scatter the mosaic plot would have changed the order as well. You would have had yes and no down there, and the core VIP and value up there. It all depends on how you want that. That doesn't matter much, but still, if you have a specific order, just ensure that you are careful. For example, here you put segment in the row and then churn the column. So segment is appearing here in the x-axis and the column is vertical axis. Okay. We want a title to that. We want to do plot.show to avoid all these different information here. By the way, if you do this, as I said to you earlier, or you can without plot.show, you can get it done without any problem. But if you want, you can still use that plot.show that you are used to. So let's put a title to that. We'll say plot title. And then the plot title, we can just call it whatever we want. Mosaic segment by churn. Segment by churn. And then we want plot.show, plt.show. That's what I want. So let's execute that. Here we go. We got our plot and the mosaic plot here. Again, I skip the interpretation. Please just consider the previous video for the interpretation. That's the mosaic plot. The last thing I want to talk about now is the stacked bar chart. Stack bar chart or conditional proportion or whatever you want to call it. Let's say markdown, execute, and we are going to do that stack bar chart. To draw the stack bar chart, it's very simple. What I need to do is to build the proportions first, and we already did it, by the way. We already did it. Let me just find this out. Where this? You remember that? pd.cross tab, etc. We're going to need that obviously to be able to do this stack bar chart. And then we will say dot, and then we'll put the plot stack. And then in the plot, we can say kind equal to, and then we'll say bar. The only thing that we need to add to this plot is we need to say stacked equal to true. As simple as that. If you want to draw this, and you can just put your plot.show, you can just put this here, you will get your stack bar chart as you see. By the way, let me just show you something just for information. If I do this and I execute that, you will see there is an error because this dot is not with that whole line of code next to it. So sometimes if you want to have them connected, you have to write your lines in different codes. You can just put slash here. Normally, when you're doing this slash, what happens is that it will automatically connect to the next line of code, especially if you have lengthy code within a single line that you don't want to have. You can do that for information, and that is supposed to work. Just give me a second with you. Yes, I need to erase that, and then we are going to execute that, and it works. Don't put a space after that, please, and then you will get it to work as it is here. That's the same thing, just for information, but there is no need for that. If you want, you can just put everything in a single line of code. By the way, plot.show, I repeat, if you can do that, or you can just put this, it ends everything and you get the graphic very nicely. I'll show you another one, which is also very interesting, an interactive bar chart in Plotly again, we are going to say we've already been loading Plotly Express, so we are going to say we want to draw a bar chart. But for that, you will see that it's a bit not contradictory, but strange what I'm going to write. So I will say I want to draw a histogram, but it's not really a histogram that I'm going to draw. You will see in a moment. Then you will see that you need to run the histogram on df, and you will see that x is going to be equal to segment. So what is different here? It's a bit a different kind of stack bar chart where I am um, putting the churn. Like here, you've got the core, you've got the core and everything, core VIP value, but I want to add a faceting to this concept. I want to add a facet by channel. For example, I want to draw the same thing but by different channel, just to see if there are some differences with regards to the channels. So if I want to do that, I can run an interactive plot as follows, and then I will say segment y and color equal to churn as usual, because there, if I stop there, it's basically the same thing that I'm doing here, but the only difference is that I'm going to have a facet here, faceting, and I will say facet um, column, facet column is equal to channel. The facet column is equal to channel means you are going to have this graphic here divided into three different panels: one for the online channel, one for the store, and one for the partner channel. Right? That's what I want. And you will say, look at that, bar norm equal to percent. Automatically, the moment that you have set a categorical, even if it's called histogram here, the moment that you have called a categorical variable and you have said bar norm percent, that will revert to a stack bar chart. Okay. Now we can end by doing figure show, and then we execute, and we will get our stack bar chart as you see here. But I can also change this thing here, count normalize as percent, by adding another argument here. We will do fig update layout, and there you will say y-axis underscore title equal to percent. Okay, and you execute the whole thing, and then you will see that this changes as you are seeing. So here you will see that you can play around with the interactive part where you can see what this represents. You will see that there is for the channel core, there are about 75% of people who are from the who have churned, who have not churned rather, who have not churned. From the channel store, you will see that no one has churned from the VIP segment, and so on and so on. You can play around with that. So if you want just to see a little bit, you can you can pan. There is something that we call panning. Where is that? Here we go. You can play around with that if you want to increase a little bit to get more information there, and you want to see, for example, up to 80% what's going on, things like that. You can do that, and you can go to scale and get back to what it was originally. Here we go. That was the end of multivariate exploratory data analysis part 3. I hope this video has been helpful to give you some insight in terms of how to draw the same graph and that we have done in R, but this time in Python. I repeat, there may be some codings that might be a little bit tricky for you to understand, but as I said to you, it's not the purpose of a course to make you write codes, all right? But you still need to understand this coding whenever there's a requirement for you to interpret the codes, or at least understand what's going on in the code. You would understand, but you don't need to write the codes in the class test, for example. All right, but you still need to understand what these different codings are doing. If in case a question comes in the class test related to these codes, at least you will understand what they are doing. That's the most important thing. Thank you for your attention. Take care.